Welcome. In this demonstration, we're going to do a principal component analysis using R. And so what I have in front of us is the R environment via RStudio. And the first thing that we need to do is to set our working directory. So if you know how to enter the path and you know the long path that your file is stored in, you can certainly type that in. But there is a shortcut for doing this. Now, when you go to create a script in R, you can create a new tab by simply selecting this R script. You'll get an untitled one, and then you need to save it somewhere. Well, I've already done that with this PCA demo. It's pcademo.r. I've saved it to a location. And once I do that, then I'm able to use a shortcut. So I can go up here to Session and set working directory to the source file location. And as soon as I click that, down here it enters the command set working directory, and then it provides that long path. Now this path is not terribly long, but you know, sometimes your files get embedded in multiple directories, and so sometimes this is the easiest way to do it. In fact, I think it's always the easiest way to do it. Now, of course, that's down in the console, and you can't save that, so you can just copy that up to your script file, and then you're able to run that at any time, so you can save that file. And I'm going to add a comment that just tells us what we're doing. So the pound sign there, set working directory. Okay. Now the next thing we need to do is to load, oops, I keep hitting the wrong key, it's the pound sign, load our CSV file. And part of setting the working directory is now I can simply load that CSV file without telling R where it's at, because it's in the same folder that I placed my script file. And so my command for that is going to be, so this is my variable name, serial. We're going to be working with serial data, as in Captain Crunch and other types of serials. And I like to use a .df just to remind myself that it's a data frame. Of course, that's R's version of somewhat like a spreadsheet, a worksheet in Excel, if you will. It's called the data frame in R. And so we can enter the command, and you'll notice that we have options that pop up here, and we're going to use the .csv. Now I can finish typing it, I can look at the help here, or I can just enter the tab. And then inside quotation marks, I'm going to enter the name of my file. Now, note that R is case sensitive. So serials with a capital C is different than serials with a lowercase c. So you need to pay attention to the names of both your variables and your files and that type of thing. Now, I've entered that into the script here so that I can save it. And notice that the name here is red, and which means I've made some changes and it's not saved, so I can simply push the save the current and it goes back to a black name. So I've entered that here. Of course, it doesn't run unless it's down in the console. And what I can do is I can place my cursor on that row and simply push the run, and then it runs the command down here. Now I could have just as easily typed that command in down here, but I like typing the commands into the script window simply because I can save them, I can come back and edit them later. When I have an error, I can play around with several different options to see what's working. Now, the console will always reflect the commands that we're running that are actually executing, much like we did with the menu options. We get those commands down there, so it's a great way to grab things and do some shortcuts. And one of those is we can actually come over here to this serial.df. So remember, that's what's called the data frame in R. And it's somewhat like a spreadsheet or worksheet in Excel. And so if we select this, notice that it brings up a tab over here and shows us the rows and the columns, more properly called attributes here, and the names of those. And also notice down here that we get the command that was done, which is that view and then the serial.df. So again, I'm going to copy that and I'm going to place it up here, and I'm going to put the note here simply to tell myself what I'm doing. It's always good to comment. Place many, many comments in your code to be kind to your future self, because you'll come back to this in some time, a week, a month, a year, and you'll scratch your head and wonder what you did and why you did it. So always, always add many, many comments. Okay, so we're focused on doing a principal component analysis here. So let's talk about what a principal component analysis is, using two of the attributes from this data set that we have about serials. And what I'm going to do is I'm going to create a plot. So what I want to do here is we're going to do a scatter plot. Again, this is just a comment to tell us what we're doing, and we're going to do it of both calories. Sorry, I had to peek to see how to spell it, and then health dot rating. Now, if you'll notice that in this, with these attribute names, we can get that there, and it's all lowercase. Remember, R is case sensitive. And also notice that this with this health dot rating, there's a dot in there. Now, if you were to look at the CSV file, there would be a space in there, but R doesn't handle spaces with the attribute, so it replaces that space with a dot, so we need to use that dot. So we're going to be using both of those. Now, of course, there's a comment, so I could have left off the dot, but it's just a good reminder to use the actual attribute names that are listed. Cases, any punctuation that's there. All right, so the function that we're going to be using is this plot command or plot function, and so the attributes that we'll be providing to this function are the serial.df. So notice that it pops up there, and again I can push the tab. And then the symbol that R uses to get one of those attributes is the $sign. And then notice that I have all these attributes available to me. And this saves me from typing it, and it especially saves me from mistyping it. So I can just scroll down to the bottom here and do that. So now when I run this, now notice again by hitting enter, pressing enter, nothing runs, because this is just a script file that I'm creating. But I can put my cursor on this row and select the run, and it creates this plot down here in this lower right hand window. Now this window has many things. It has lists of packages and helps and file browser if you need it, those types of things. But what we're interested here is this plot. So we're taking the calories and we're plotting them along with the health rating and kind of looking at the relationship. So with a PCA, the principal component analysis, what we're analyzing is we're analyzing the variance in sets of attributes. And I say sets because it could be two or more attributes. And we're looking at those variants. Obviously, if it's more than two, then it's difficult for us to visualize. So we're sticking with two in this case. So I want to add a couple of lines. And these lines are not, they are not calculated lines. They are simply illustrative of what happens. So I'm going to add my PCA, Principal Component Analysis, lines to illustrate this. We're going to use a function called segments. And I have the X and Y coordinates for you. And now I did do some playing around with these X and Y coordinates to ensure that they're relatively close to what this would be. But remember, it's not a calculation, it is an illustration. Now I'm going to set the color of this one to red, and I want the thickness equal to 3. LWD is for the line width. And again, I hit enter and nothing happens. Let's go ahead and type in that next one. And this one is at a right angle to it, so I did calculate the right angle so we could get proper lines. And we're going to go blue there, and same width. Now it's at a right angle because when we're looking at variance and we're looking at principal components, we want principal components, meaning that there's no linear relationship between those components, which implies this perpendicular linear relationship. So let's draw our red line by placing our cursor there and selecting Run. And notice we have a red line here. Now, this line depicts most of the variability in the relationship between these two attributes. And if we put that blue line in that is perpendicular to it, we can see that there's some other variability that goes this direction, but it's not as much. Now, I can't create that by eyeballing it. I actually have to do the PCA analysis and then go back and add these lines for explanation. Well, I guess you can kind of eyeball it. You can see that it's spread out more this way than it is spread out this way. But remember, it's just an illustration of what happens when we're doing a PCA. The math behind this we don't even need to get into, but this is kind of the visual picture of what happens. Variability is what we're interested in. The next thing we'll do is actually the PCA analysis for those two variables that we're using. And so I'm going to create another variable. So I can name it anything I want. It's PCA2 simply because I'm using two attributes, and that tells me. And so the PCA, the principal component analysis function, is prcomp, and I will be using the two attributes that we just worked with, calories and rating. And to do that, I need to specify these as a data frame. Remember, a data frame is the idea of a worksheet in R. And then I need my two attributes. And again, I can just enter these. I can either type them, but it's much easier to use my drop down. Now I can use the up arrow and go to that end there. And I should have all my parentheses in there. They're inserted by default when I use that tab. So I can come up here and run this. Now, when I run it, again, notice that down here in this console window, it displays here, but there's no real output except for it lists it up here. Now, I could click on this, but it's actually a list, and it's not that helpful to look at in your upper left-hand window. We want to explore it with what's called a summary command. And so if we type in summary, and then we type in that name of that variable, PCA2, then we can run it. And notice what we get down here at the bottom. We get the principal component 1 and the principal component 2. Now, again, I've illustrated these with this line. So the red line is principal component 1. That's where the most variability occurs in these two attributes. And of course, we're talking about linear variability. Now, we can see that by this proportion of the variance right here, and we can see that 86% of it occurs in principal component 1, and that only 13%, or call it 14%, occurs in principal component 2, which would be that blue line. Okay, so whenever you're doing a summary of this, and it may list PC1, PC2, and on, we'll actually do the principal component analysis using all 13 attributes in this data set and see this in a moment, that you can look at each principal component to see what proportion of variance it's capturing. Then we can see our cumulative proportion. Now, we only have two, so the first one matches the principal component 1's variance, and the second one is 1, or 100%. Okay, the next command we're going to enter is the rotation command for that PCA. And so we're using the variable, and what I want to pull out of it is this rotation. Now notice again, I've used the $ to access the various attributes inside of this variable. And so what we want in this case is the rotation. Now, the name is maybe not as explanatory as it should be. When we run this command and look at the attribute for the rotation inside of this PCA2, what we see are the percentages that each of the original attributes contributes to each of the principal components. Now that we've explored what happens in a principal component analysis, let's actually do one with all 13 of these variables in this data set. So I'm going to go to the script window and type in our comment here. And this is a PCA on 13, and it's going to be standardized variables. So let's talk about that for a moment. So there's times when you want to standardize the variables and times when you don't. And it'll help us if we're looking at the variables or attributes here for this. So there's times when you want to standardize the attributes, and there's times when you don't. So let's see, the units of measurements. So when we're looking at the units of measurements, calories are the number of calories in a serving. What else do we have here? Fat is in grams, sodium is in milligrams. Let's take a look at vitamins. Vitamins are actually a percentage of the recommended daily allowance. And we have things like shelf, which would be the shelf number, 1 being the lowest, 2, and then 3 up higher than this. So this is a critical situation for standardizing these measurements. So you want to standardize attributes really under 2 situations. One, that they use different units. And so we can look at shelf and say, well, it's a shelf number. And we can look at calories and say, well, it's a calorie count per serving. Those are obviously different units, and so we need to standardize those. The other situation is if they're using similar units, but the scale does not reflect the importance. And fat and sodium would be examples of that. So fat is in grams and sodium is in milligrams. Now, I know those aren't exactly the same units, but they're both grams. And we could certainly think of fat in milligrams. But the scale is not significant in this case. It doesn't reflect the importance between the 2 variables. So we need to standardize these. Now, I'll show you in a moment how to standardize them, but there are reasons for not standardizing, and it would essentially be the opposite. So when your variables are on similar units, and the scale in those reflects importance in the variability. To standardize these attributes, we'll be using a parameter in our PCA function, and that parameter is simply scale. We'll set it to true, and then it will automatically standardize these for us. The other thing we have to consider is that there may be some missing values in here. Now I'm going to include the code for taking care of missing values, even without inspecting the data to see if there is or not, simply to illustrate that. So when we go back to our script window, I'm going to use the variable PCA13 since I'm using 13 attributes in this, and my function here. Now, NA omit, so I want to omit any not applicable NA values. So what R does, if there's a blank spot, it plugs in an NA value, not applicable. And we want to eliminate those, and we're going to use that entire serial.df except, and this code right here will eliminate our first 3 attributes, the first 3 columns, if you will. We can look back at this and see that that's the manufacturer, or I'm sorry, the name, the manufacturer, and the type, cold, or the H. I believe there's some H's here. Yeah, H for hot. We don't want to include those. So what I'm going to do is enter a command where I tell it don't include, that's the negative sign, so don't include these columns, and it's going to be columns 1 to 3. And then finally, what I want here is after I've done all of that, so right here, I want that scale, and notice it comes up here and I can read about it, and that's the one I want. I'm simply going to set that to T for true. So I do want it to standardize those attributes. So this is my command, and I'm going to go ahead and type in my summary. And and my rotation now. Notice that window didn't come up, so I can simply type it in here. As long as I haven't made an error in typing, I should be good. So we're going to run the actual PCA process with those changes that we've made. Now it's telling me I have an error here, so let's go back to that command. This is a great reason for using this script file. And so I want, this actually is supposed to be closing bracket. These are supposed to be parentheses, and I typed the wrong symbols in there. So that should do it. Now notice when I had one of those missing, that I had an X over here, a red X, and so it can kind of help you with some troubleshooting when you see those. But I want a parentheses there, and we're going to run that again. And so I have an output, and I have my PCA object up here in the object window, and then I want to run my summary. And I can look again at all of those principal components. Now there are 13 total principal components here, and I can begin to look at that cumulative proportion, 30%, 52%, 67%, so on and so forth. If I wanted 99%, I would have to come clear out through the 10th principal component. Now, I don't necessarily need to go that high. I might be satisfied, let's say I'm satisfied with this 88% of my variability. So the thing to realize is that a PCA, principal component analysis, is used to reduce the dimensions. It's a dimension reduction process for numerical variables. We don't use it on categorical variables. We use it on numerical variables. And we're reducing the number of those variables or attributes, called dimension reduction. And there's going to be some information loss. Now, it's doing a linear transformation on this, so it's actually a weighted linear combination that it's doing, and so we're capturing as much of that information as we can. But the kind of information loss we're going to get is wherever that cutoff is that we choose, that will be one kind of information loss that we'll get. So if I'm satisfied with 88%, then I know I'm losing 12% of that information, linear information. The other kind of information loss would be nonlinear information, because the principal component analysis is doing this weighted linear combination. Okay, so we can also see the proportion of variance that each of these is contributing. It starts out at 28% and it just gets lower and lower, and down here at number 6 we're just at 6%, and those continue to drop off. So we might be happy with the first 6 principal components. So let's run our rotation. Now I'll expand this window here so we can see all of this. And notice that it lists all 13 of those attributes that we used. And for principal component 1, the weight that they're contributing to that principal component. And we can look down at this, and we've got a pretty large one here, a negative 45 for fiber, negative 40 for potassium. Let's see, we've got a negative 43 for the health rating. Now, those are all negatives. We've got some positives that are high, positive 30 for the cups that are involved in the servings, positive 30 for the calories, so on and so forth. You can take a look at those to understand the principal components in this PCA analysis. So what we would do with this is essentially we've created a new set of attributes that we can use for other data analysis by going through this principal component analysis. And given our cutoff that we chose of 88%, we've reduced 13 attributes down to 6 attributes. And in some of the processes that you follow, this is very important. You need to have a fewer number of attributes. And so you'll run a PCA.